In today's video, we'll be learning part 1.1 of chapter 1 chemical reactions and equations. In this video, we will cover writing and balancing chemical equations. What is a chemical reaction? A chemical reaction is a process in which one or more substances, these are called reactants, they come together to form a product. In this process, bonds between the atoms in the reactants are broken and new bonds are formed to create the products. These changes result in new substances with different chemical properties compared to the ones that we started with. What are the key characteristics of chemical reactions? First one is there is always a formation of new substance or substances in a chemical reaction. Second is that sometimes there are changes in energy such as heat and light, etc. Sometimes there are also permanent changes in color, odor or taste. Production of gas or fizz or some solid particles can also be observed. Some chemical reactions can also be irreversible, but not all of them. Let us take a look at some signs of a chemical reaction. How do you know a chemical reaction has occurred? In the first example, we can see a color change. For example, when iron rusts, you can see that it goes from silver color to brown color. Second example shows us a release of energy. When you burn wood, you can notice a release of heat. This is an example of temperature change. Third example shows us the formation of bubbles. You might have noticed when you add baking soda to vinegar, you see something called fizzing and bubbles form. This is also a sign of chemical reaction. Another sign of chemical reaction is the formation of a precipitate. You must have observed when you squeeze lemon juice into milk, it curdles. Lemon juice is a liquid, milk is a liquid. But when you're putting them both together, it's forming a solid. This is called a precipitate. And this is also one of the signs of a chemical reaction. Now, what is a chemical equation? A chemical equation is a symbolic way to represent a chemical reaction. It's going to show us the reactants and products and in what proportions we have those reactants and products. Reactants are the starting substances in a reaction. Product is the new substance that is formed. Here we can see an example of methane reacting with oxygen to form carbon dioxide and water. Here we can see one methane molecule and two oxygen molecules are forming one carbon dioxide molecule and two water molecules. This equation represents the combustion of methane. Here the reactants are methane and oxygen and the products are carbon dioxide and water. Now, a balanced chemical equation. A chemical equation is balanced when the number of atoms of each element is the same on both sides of the equation. Why is balancing chemical equations important? It is essential in chemistry to ensure that law of conservation of mass is followed. This law states that matter is neither created nor destroyed, meaning number of atoms must be same on both sides of the reaction. We can see an example of an unbalanced equation here. We can see two hydrogen molecules and two oxygen molecules are forming one water molecule. However, here in the water molecule we have two hydrogens but only one oxygen. In order to balance this, we need to balance the equation on both sides, and the balanced equation looks as shown in the screen here. Here we can see that we have 4 hydrogen molecules on left hand side, which is balanced by the 4 hydrogen molecules on the right hand side as well. Similarly, we have 2 oxygen molecules on the left hand side and 2 on the right hand side. This is called a balanced equation. How to balance a chemical equation? First step is to write down the unbalanced equation. Here we can see iron and oxygen reacting to form iron oxide. I have written down the unbalanced chemical equation. Here on the left hand side I have 1 iron, on the right hand side I have 2. Similarly, oxygens are 2 on the left hand side, but on the right hand side there are 3. The next step is to list the number of atoms, preferably in a table. So upon listing, it looks like this. Left hand side and right hand side number of atoms are listed. The next step is to balance one element at a time. It's better to start with iron and adjusting the coefficients to make the number of atoms equal on both sides. Now I have adjusted the iron atoms here. I have added a coefficient of 2 on left hand side. Now both iron atoms are balanced. Next step is to balance hydrogen and oxygen. It is always best to balance hydrogen and oxygen in the end because they often appear in multiple compounds and it is easier. Now, upon balancing the oxygen atoms, here on the left hand side I had only 2 oxygen atoms, but on the right hand side there were 3. So I added 3 on the left hand side and 2 on the right hand side. But this meant I also have to balance iron atoms again. So an overall balanced equation looks like this. Now, after balancing the equation, we need to check if all the coefficients are whole numbers. Here I have two coefficients on the left hand side, 4 and 3, both are whole numbers. On the right hand side I have a coefficient of 2, that is also a whole number. So it is necessary that all the coefficients are whole numbers. You cannot have fractions or decimals. The final step is to check our work. So we have 4 iron atoms on the left side and 2 into 2, 4 on the right hand side as well. I have 3 into 2, 6 on the left hand side for oxygen and 2 into 3, 6 on the right hand side for oxygen as well. So I can confidently say that this equation is balanced. Now let's take an example of balancing the equation for combustion of propane. Let's write the unbalanced equation. C3H8 plus O2 gives CO2 plus H2O. Second step is to list the number of atoms for each element. Now I have created a table here and have listed carbon, hydrogen and oxygen. Here I can see all of them are unbalanced with different numbers on LHS and RHS. Now the first step is to balance the carbon atoms. I have placed a 3 in front of CO2 to balance the carbon atoms, and now I have 3 carbon atoms on both sides. Next step is to balance the hydrogen atoms. Placing a 4 in front of H2O will help me balance the hydrogen atoms because I have 8 on the left hand side and only 2 on the right hand side. Now there are 8 hydrogen atoms on both sides. Step 5 is to balance the oxygen atoms. Here I have 2 oxygen atoms on the left hand side from O2, but on the right hand side I have 6 oxygen atoms from CO2 and 4 oxygen atoms from H2O, total of 10. So in order to balance, I need to put a 5 in front of O2. So the balanced equation looks like this. C3H8 plus 5O2 gives 3CO2 plus 4H2O. You can use some of these unsolved examples for practice. Here I have 3 examples listed. You can pause the video here and try to balance these equations, or you can see the answers in the next slide. This slide gives the answers for the balanced equations for the questions we saw in the previous slide. Now that we have learned how to balance chemical equations, we should also learn how to write state symbols to these balanced chemical equations. What are physical states? So a physical state is often indicated using symbols placed in parentheses after the chemical formula. The common symbols are for solid, liquid, gas and aqueous. Aqueous is nothing but a substance which is dissolved in water. We usually use the symbol AQ wherever there is a solution. Now let's take a look at how to assign these physical states in a chemical reaction. The first step is to identify each reactant and product and in what state they are. The second step is to assign the symbols to each of these substances. And the third step is to balance the equation. Let's take a look at an example. Here I am taking an example of combustion of methane. CH4 plus O2 will give me CO2 and H2O. Now, identifying the physical states, methane is a gas, oxygen is also a gas, carbon dioxide is a gas, water is formed in the form of water vapor because it's a combustion, and this is also a gas. So let me assign these state symbols to this equation. Now adding physical states, the equation looks like this. The next step is to balance the chemical equation. Now upon balancing the equation looks like this. Let's take a look at another example of writing physical states in chemical equations and balancing them. Here I am taking an example of reaction of zinc with hydrochloric acid. Zn plus HCl gives me ZnCl2 plus H2, that is zinc chloride and hydrogen gas. Now let me identify the states first. Here zinc is a solid, hydrochloric acid is an aqueous solution, zinc chloride is formed in the aqueous solution form and hydrogen is a gas. Now upon adding these physical states, the equation looks like this. The final step is to balance the equation. I've balanced the equation in order to add 2 hydrogens and chlorines on the left hand side, and the equation looks like this. Here are some unsolved examples for practice that you can use for practicing assigning physical states as well as balancing the chemical equations. You can pause the video here and try to solve these questions, or the answers for these questions are given in the next slide. This slide gives us the balanced equation with physical states for all the questions that you saw in the previous slide. With this, we have come to an end for part 1.1 in chapter 1.